Hey everyone, Ashok here. Welcome to another quick session on DevOps toolchain. This video, I'm going to talk about Docker very briefly, about the theory, what is Docker, why it is popular, and then we quickly move on to hands-on, where we spin off an Amazon cloud server and do some basic commands on Docker. All right, let's get started. So what is Docker? To understand this, we need to compare virtualization wise containerization. The Docker is the popular tool for containerization. So if you have an idea of virtualization, you would have realized that in virtualization, we actually divide physically the resources for individual virtual machine. So what do you mean by that? We actually reserve the RAM and computing space for each and every virtual machine. So we can have multiple virtual machines on a single machine or the host machine you call. The disadvantage is poor resource utilization and it takes a lot of time to boot up. Okay. When it comes to containerization, yeah, this the left side is an architecture for virtualization and the right side is containerization. You can clearly see that in virtualization we have the server infrastructure and host machine, of course, the host machine operating system, and we have a virtualization software. It could be a VMware or hypervisor, and on that you have virtual machines, and each of these virtual machines have a guest OS or it has its own operating system, and that's one of the reasons why it reserves the space and it takes a lot of time to boot up. Come to containerization, you completely eliminate this guest OS part. The container engine abstracts host machine operating system required libraries and the commands, and it runs containers. So containers are very lightweight. It has its own libraries and binary files along with applications, and it can quickly spin off. And I say quickly, it can spin off in fraction of seconds, right? All right, we're going to talk about a few of these things. When it comes to virtualization, as I told before, if you want to break this machine which has 32 GB into three virtual machines which contains 16 GB, 10 GB, and 6 GB, all right, the utilization may not be full. Maybe the first virtual machine is only using 10 GB, which means 6 GB is free, but it cannot be used for anything else because it's reserved by virtual machine 1. The same goes with 2 and 3. So there are about 13 GB unused memory blocked by virtual machines. This memory cannot be reallocated. But in case of Docker, these containers run as more like a process. So it only consumes computing space or memory as required, which means about 13 GB is still available with the host machine. It can be used for launching new containers or some other applications, right? That's the memory part. And this translates to huge millions of dollars if you're looking at a large scale infrastructure in terms of savings. Docker components. Docker has a few components. We say the client machine is the machine you are running, the Docker containers, uses certain commands, build, pull, and run. And this Docker host, which has all the containers and images, and it's been all this is connected by Docker daemon, all right? And the registry, we can call this registry as Docker Hub because that's most popular and official Docker repository or registry. You have all uh, the images. It could be Linux distribution, Ubuntu, it could be an Oracle software, it could be a Puppet, or it could be anything. It's all available on the Docker Hub. We will take a hands-on experience of this in next few minutes. So this is Docker Hub, and it has more or less almost all the softwares you probably use in today's world as a well-configured image in Docker Hub. Let's quickly go to the Docker Hub. Okay, I'll just open up my browser, Google Chrome. All right, so hub.docker.com. Okay, and sign in. I have bad memory, but I guess my ID is Ashok66, and it was successful. Okay. I have my own uh, repository created over here, just one, and this is Docker Hub. You can almost find any software images over here. What I mean by that, let's look at Puppet, for example. So Puppet server, Puppet. Oh, let's look at CentOS, a Linux distribution. We'll have an official version of CentOS. About 10 million pulls been done, and it's been rated 5 star for more than 4,000 users. Okay, pulling this, installing this image is really easy. Next, we're gonna see that. If you're following these tutorials, I suggest you create your own Docker Hub account. It's free, and in that way, you can follow with me. Okay, and next thing is let's actually go ahead and spin off an Amazon cloud server. I'm going to sign in, and most probably it will directly go in because I am already signed in. I'll go to EC2, stands for Elastic Cluster. So that's the Amazon Web Service. I have one running instance. I'm going to launch a new instance. It takes actually no time. I'm going to say review and launch. I will go to security groups. As of now, I'm going to allow all my connections because this is a test server. If you are running a production server, you probably restrict to HTTP and HTTPS if it's a web service or other ports based on requirement. SSH allows you to connect from your SSH client, PuTTY, if Windows, in Mac we use Terminal or any other client. But as it's a test server, I'm going to just keep everything open from anywhere I can connect from any port, just because it's a test server. Okay, and it's gonna obviously show a warning saying, it's too open to the world, but I am ignoring it. If you're doing a production server, you would be required to set up the things accordingly. Launch, and it's asking about key pair. I'm going to type a new key pair saying Docker test server, Docker test server key, AWS key. I normally keep it as descriptive as possible because just looking at the key you can't really make out anything, so you need to be more descriptive. That's it, and I downloaded the key and launched the server. Let's take a quick look at it. It takes few seconds and it should be up and running. In the meanwhile, I will say Docker, I'll name the server Docker test server. Alright, and here we go, it's running. And this is your public IP. You don't see anything now because there was nothing running on it, no web server, so it can't really respond to the request from a browser. Alright, let me see this key. Okay, it is in downloads folder. I'll just move it to Ashok folder. Just Docker test server AWS key. Okay, good. Now I move to my terminal, and connect to this cloud server. Okay. Hope it's clear and visible. Okay, good. So I have my key here. I'm going to simply say SSH minus I, and I will type in my key, and that is, where is my key? Docker, yeah, great. And that's it. I can, okay, before that, the key has to be, okay, let's try. EC2 user is the username at, and the public IP number. I'm not expecting this to connect because it will throw an error saying yes. It says bad permission for the key. Yeah, true, because the key has to be at 400 permission. It should not be accessed by outside Now it will connect. Great. So we are right now in Amazon server. As you can see, this is the internal IP number, and this is the user. I'm logged in, and I'm in the cloud server now. As a good practice, I normally upgrade or update my server when I just logged in. So just I said yum update -y. It installs all the latest version of the packages which has been already installed. It takes a few seconds. All right, here you go. So we have a server installed. Great. Let me go back to the slides and let's practice some few commands. Docker pull, Docker run, Docker image, what are they? Rather than explaining in the slides, I would go to the terminal and I would say Docker. Well, Docker is not installed yet, but installing Docker is just one command. You say sudo docker yum. Here's my installer, install Docker. That's all. And say yes. All right. And your disk has critically maybe automatically discard. Okay, no problem. Once again, is this talking about my disk or the cloud disk? I think it's my disk. Yeah, no, that's not the case. All right, so I just installed the Docker. Let me see. Okay, so that's Docker commands, and it basically means that Docker has been installed. Clear. I will also add a user called Docker as a moderator in the user group so that I don't have to type in sudo every time. So I will say I will add EC2 user, which is my current user, as one of the Docker admin users. I will exit and I log in again to get this. Okay, now I would say Docker, it will run. Okay, so I have installed Docker. Let's practice few commands. Here is our slides. Okay, so pulling an image. Great. Let's pull an image. Pulling an image, it actually pulls from CentOS. Oh, sorry, it actually pulls from the Docker Hub. So let's pull this image. All right. So I can look into the details. I'll just go details, and this is CentOS, latest build. Okay. To pull this, I simply run a command docker pull CentOS. If I don't mention any version, it's going to take the latest. It says Docker is not yet running. The Docker daemon has to be running. Remember our previous slide? Running the Docker daemon is sudo service docker start. Because I'm running Amazon machine, now the Docker daemon is running. Clear. Now I pull CentOS. Okay, it's pulling. It's about 72 MB or 73 MB. So we have the Docker image being pulled. To see what are the images I have it in my local machine, I say Docker images. It will show me CentOS latest version, and this is the image ID. It's been created 2 weeks ago by someone from CentOS team, right? And the total size of this image in the local disk is 195 MB after extraction. All right, so I can spin off a Docker container from this image right away. Before that, let me just show you the flow. You don't need this. So this is the run stop commit flow. We download the image now. The image is in local. To run it, we simply use docker run command. And then you can see, you can log into the image and you can check you have a running container with that image. And if you exit it or simply issue a docker stop command, the container will stop. And you can actually commit that container with a new image. so that the changes will be stored over there. So let's just do it what I mean. I'm going to run a container from this image. For this, the command is docker run. I use -it for interactive terminal so that I can log into, I can interact with the container in this window. Right? I'll say CentOS. That's it. So as you can see, the prompt has been changed. Now I'm in a container. I'm in a container and I am logged into a container. I just want to see what is this container release, because we have downloaded CentOS. So I can simply use the command cat and lsb and release cat lsb release. It's in etc folder. Yeah, root folder that contains all your releases. Not working. Okay, so you have a running container. Let's just log it. Yeah, so we are in the container now. Let's just do some look arounds. I'll just go here and see what are the files I have. And yeah, this is pretty much your container. Let's see if the Git is installed. No, the Git is not installed. All right, let's go ahead and install the Git in this container and see how it works. So this container is CentOS. So I can use yum sudo yum install Git. I'm already in the root. I don't need sudo. Okay, I'm installing Git inside a container. Just to show that we can install softwares inside a container. They act exactly like a physical machine, right? So we don't have any restrictions of installing softwares or do anything with it. Well, to make it access outside, it's a more advanced concept. We need to do a port forwarding so that this container can be accessed from the outside world. Okay, it has taken a little more time than I expected. Git is normally very fast. It's installing all the dependencies. Complete. So we have Git being installed. Fantastic. So great. I'm going to exit the container just like that, pressing exit. I'm back to my host machine. As you can see, easy to user. All right. And if I go ahead and look at my all the running images, containers, I don't have any because I just stopped one. But if I say ps -a, show me all, it shows a container from a CentOS image been spinned off like 3 minutes ago, and it got exited like 18 seconds ago, just now, and it has given some nice name to it, quizzical column. So we have stopped the container. The stopped instant is available there. Okay. If you want to preserve this container with a different name, with a different image, we could actually do it by using commit command. So I can say commit this container ID and give a name of the command. I'm going to just do that, docker commit, and I put this container ID and say CentOS and Git. So basically I have installed Git in the CentOS server. Now I have a CentOS Git image. Enter. There is no such container. Oh, okay. Oh, sorry. Somehow that container ID is not being copied. Okay. Paste. All right. Great. Clear the screen. and say Docker images. Now I have two images. One I downloaded from the Docker Hub. Now other one I just created. This is an image which contains Git being installed already. As you can, the size of this image is pretty high. It has about another 160 MB more. I assume that that 160 MB is actually Git software being installed. Okay. If I spin off this container, the container which is with the image as CentOS Git, I should be getting it with the Git being installed in it. Shall we try that? Docker run, I use -IT for interactive terminal. I'll say CentOS -Git. This is the image we have just created. Great. So I'm into the container now. Okay. Let's type in Git. It works. Basically, we have downloaded a CentOS blank, like barebone flavor of a Linux, and we installed Git software in it. We bundled it again. I'm going to exit this container. So we bundled it again as another image called CentOS Git, and we have run this image, and we see that whatever softwares and configurations, whatever we have done in the image is being preserved. Okay. That's one of the major advantage of Docker. We call it as shippable. We can bundle the images and we can ship it. Let's see the next version of push and pull. What does it mean is you can also push this image to the central repository, okay, or your own private. So I'm going to push this CentOS Git into my Docker Hub account. Okay. In order to do that, I need to tag it with my account name. Like Ashok66 is my Docker account name. So let me tag that. So I would say Docker tag image ID. Oh, sorry, this one, right? Image ID. And I want to tag it as Ashok66 and CentOS Git. All right. Now let's see how many images we have. We should have 3 images. One is like we downloaded from the CentOS like GitHub. Another one is we just committed this, and we have tagged a new one with Ashok66. And pushing to that, I need to first of all log in. Say Docker login, and I can use this username and put in Ashok66 because that's my username. It's going to ask me password. I give my GitHub password. It will say login succeeded. But when login succeeded, I can simply push it. Pushing, the command is pretty simple. Docker push, and I'm going to push Ashok66 CentOS Git. That's all. So we are pushing about 400 MB image into my repository in Docker Hub. It's done. Well, it will compress and push it. So now it's like around 158 MB. Let's go into my Docker Hub account and check whether we have received the image or not. Okay, as you can see, I just pushed it. So this is the image. I have it in my Docker Hub. If you want to pull this image, you can simply say Docker pull Ashok66 at CentOS-Git, and it will be working. All right. So the idea behind this video is to give you a quick start about how easy it's in the Docker to actually spin off a container, shut it down, log into a container, connect to the Docker Hub repository, push and pull. Everything can happen in a very easy manner. One last thing I want to cover in this quick tutorial is persistence. You might be wondering, where are these files stored? Well, these are stored in container which are not persistent, which means if you stop the container, if you don't make an image of it, then all the stuff which is in the container is gone, right? If you want to make it more persistent, we have a small option in Docker run called as -v, that is volume. So what we can do is we can actually we can map a folder in the host machine to a folder in your container. So whatever stuff or whatever files and configuration, whatever you store in that folder is automatically mapped to your host machine folder. So in this manner, even if you stop the container, all the files are persistent in your host machine. And this can be used to actually spin off the container again. The same files will be loaded in the container as well. So the persistence can be achieved by using -v. It's really easy to demonstrate, but it's beyond the scope of this quick tutorial. We also have ML scripting. So you can write the entire code of the infrastructure in ML scripting, and it will quickly spin off the server, and you will see that all the script things are run as sequence. Let's do a little YAML scripting, okay, and see if we can spin off some nice website and take a look. That will be interesting. Let's do that. Anyway, our server is up and running. So for doing the ML script running, you need to install a software called as Docker Compose. So Docker Compose is actually a Python pip software, which basically you need a Python installer. So first we install Python pip, and then we install Docker Compose. Okay, let's do that. Yum. Okay, sudo yum and install Python pip. Okay. Okay, great. Completed pretty fast. Now I'm going to say sudo pip install Docker Compose. Okay, that was quick as well. Where am I? I'm in EC2. Let's create a quick working directory. Make directory. I'm going to launch a WordPress website. So cd WordPress, and I'm going to say just compose or docker compose .yaml file. I can give any extension, right? Quickly typing in WordPress. This is the container name, and then you say image and WordPress. When you say WordPress, it goes to the Git repository, finds a latest image of WordPress and installs it. And then I have to say that this WordPress has to be working only when the DB is available. So I will take MySQL because that goes pretty good with Docker. And the ports, I want to access this from my browser. So it would be -80 port, -80 and 80. So 80 is forwarded to 80. So this one, the second container is a database container. So I'm spinning of two containers. So the way you notify is the Docker is you simply put db colon, which means it's a container, and the image can be simply MySQL. We can use all optimized versions. So I'm just showing you a very quick example. So environment, I have to mention environment because MySQL requires a password, right? And the variable name is MySQL root password all capital, and then I'm just going to use SKILLOGIC, small letters, SKILLOGIC. Okay, that is it, and I can simply run this command using docker up, docker compose up. So I'll say docker compose up -d for run it in a detached mode, right? Mapping values are not allowed here. Line 3. Okay. There should be a space because now it is just taken as one. Okay, it is now downloading MySQL as well, and it has created, it's installed. Fantastic. So it is now right up and running. Let us check if the website is running. I could quickly go here and take the public IP from here and put it. Okay, here we go. So the website is up and running, just one, like few lines, and I just give this name as Docker test site, and I just say username this one. I don't mind the password, and it's optional. I'm going to go ahead and install the WordPress. No, I have to give an email ID. Okay, I showed 66 or I showed that skillogic.com. Just give 66. Okay, install. It's done, and I'll just remove this text, and you see, voila, the site has been launched, and in two different containers. One runs a site of your WordPress, other one runs your MySQL software, and we have a full-blown site in actually few lines of commands. Let's take a look at this YAML file again. With this two, it has pulled two images, WordPress image and MySQL image from the Docker Hub, and it has spinned off two containers, did all the networking by itself, and the site is up and running from a public IP just like that. And that's the power of Docker. All right, so that's a quick overview of Docker and how flexible and easy that can be. We get a lot of questions about can I learn DevOps tools? How difficult it is? Do I need to be very technical? The answer is well, there are some scripting and certain things to be learned, but overall, configuring DevOps tools can be learned relatively easy, I would say. So if you have a bit of Linux background, admin background, that even becomes more easy, right? All right, so hope you enjoyed the tutorial. If you have any comments, leave it on the comments box in the YouTube. Do subscribe. Thanks for watching.